MDM4U 1.6 Modeling with Matrices. So a matrix is an array of numbers used to manage and organize data. And an array is a data structure containing a number of data values, all of which are the same type, and in our case is organized into rows and columns. And remember, rows are side to side, columns are vertical. So that being said, we can look at our matrix A and say that the size of a matrix is described by the number of m rows and n columns. So in this case, there are 2 rows, because rows are side to side, and there are 3 columns. So the dimensions of this matrix are 2 by 3. We use capital letters as the symbol for a matrix and represent each entry using lowercase letters with 2 indices. So that being said, this is a 3 by 3 matrix A, and notice that we'll look at this entry, lowercase a 2, 3, that's in the second row, third column. This is in the third row, first column. Similarly, B is a 3 by 2 matrix, where this, for example, is saying that this is in row 1, entry 2. And in general, matrix C is an m by n matrix, where there are m rows and n columns. Okay, so some special cases or special types of matrices. A row matrix has 1 row and it's 1 by n. So this is an example of a row matrix with 4 elements. So it's 1 by 4 are the dimensions. A column matrix has 1 column. This is a 3 by 1. A square matrix has equal rows and equal columns, n by n. This is a 3 by 3 square matrix. The transpose of a matrix involves switching the rows and columns of a matrix. Write each row as a column. So if this is row 1, 5, -2, 3, that's row 1. Then that becomes column 1, 5, -2, and 3. Row 2 becomes column 2, 2, 1, 0 becomes 2, 1, 0. So this can help to make sure that matrix operations are compatible. Next, adding and subtracting matrices. Matrices can be added or subtracted if they have the exact same dimensions. Either add or subtract corresponding entries. So if this is the definition of A and B, then A plus B is going to be made up as the following. They have to have the exact same dimensions because what we're doing is adding corresponding entries. Notice that that's in the same position for each matrix, and therefore that's going to be 5 plus 3 to make 8. Similarly, -2 plus 4 is equal to 2, and so on. And if the operation between A and B is subtraction, the same process continues. We'll have entry A11 minus B11, which is 5 minus 3, 2. -2 minus 4, which is -6, and so on. Good luck.